Hi guys, welcome back. So in this video, we are being looking at this problem from Pathfinder, Newton Laws of Motion chapter, CYU 26, and yeah, let's begin. So in this problem, we have a light inextensible cord is wrapped around a frictionless cylinder of radius r, fixed vertically on a floor that is lubricated with oil. So basically, it is situated on a floor which is lubricated with oil here. So this is the cylinder we are seeing from top view. So a bead of mass m is tied at one end of the cord and other end is p is free as shown by the top view of situation. So the end p is free here, so we have to pull it, and force of viscous drag on the bead due to layer of the lubricating oil is proportional to the speed of the bead, and the proportionally constant is k. So here the viscous force on the bead is k times v. So if the free end of the cord is pulled with a constant speed u along the cylinder, the bead eventually acquires a steady motion on the circular path. Find expressions for speed of the bead and radius of the circular path in a steady motion. Alright guys. So before solving the problem, we have to analyze the initial situation and the final situation. So initially, the free end P is pulled with a constant speed u. So initially it moves along the cylinder. So after it acquires steady motion, it will jump into another trajectory. It is also circular motion. So what is the meaning of steady motion here is at the steady motion, uh, the speed of the bead is constant and the net acceleration towards the center is zero. Okay, and after steady motion it jumps into radius r of the circular path. So it has a tangential velocity capital V, so it is unknown, we have to find it, and radius is also unknown. So it has a viscous drag here, F is k times V, and the centrifugal force mv square by r outwards. So and the tension along the rope. Okay, so we named this triangle as AOB. So from AOB triangle, sine theta equals capital R upon smaller, equation 1. And here we divide the capital V into two components. So in this, V sine theta equals small u along the cylinder from constant. So V sine theta equals small u. From this, V equals to u times small r by capital. We substitute the value of sine theta here. So this is equation 2. So we write the component of tensions, and okay, T cos theta equals the centripetal force here. So T cos theta equals mv square by r, equation 3, and T sin theta equals to drag force. So T sin theta equals k times v, equation 4. So we divide equation 4 upon equation 3. Tan theta equals kr upon mv. So from equation 2 we substitute the value of capital V in this equation. So tan theta equals k into capital R upon mu. Okay, so we construct a right angle triangle here. So theta tan theta equals kr upon mu, and this is hypotenuse. All right, so from this equation, we substitute the value of sine theta here. So we get the value of capital V, the speed after steady motion. So we capital V equals u into u times 1 plus mu upon kr whole square. So comment on the answer of the second part, guys. So if you understand this problem, do it a like, guys, and subscribe our channel. Thanks for watching.